Okay, so in this video, I will show you how to do something called an ordinal regression. Now, the first question you might be asking is, why do you want to do an ordinal regression? Why not a multinomial analysis or a multinomial regression or a binomial logistic regression? And the answer is, if you look at your dependent variable, you'll see that you've got a 0 to 3. And if you look at the categories, these categories are clearly in some sort of order. So, for example, someone who has a dependency issue is clearly worse than someone who's harmful when it comes to alcohol, whereas someone who's clearly got no concern is less than someone who is hazardous. So you definitely want to do an ordinal regression. So to do an ordinal regression, you do the following. You go analyze, regression, ordinal. Here's one I prepared earlier. So we want to make sure we've got our dependent variable there and our independence in factors. If we want covariates, we put them down there. In your example, I don't think we do. Then we go on to options. We make sure that iterations are 100, which is fine when you consider that you've only got 50. And you want the link to be logent. Okay. And then we want to go on to output. Write a couple of useful ones. Make sure all of these are ticked. They're normally ticked by default. So summary statistics, goodness of fit, parameter estimates, cell information, tester parallel lines, which is if you've got an interaction. And then you also want to tick predictive categories, which is very useful if you want to do graphs. And then predictive category probabilities, and then continue. Then just hit OK, and then we wait. So what we see is we've got some nice data, and the first thing you'll see is a warning. Now that's because SPSS worries, because if you imagine a graph, what it wants you to have is, have we got points on here? Yeah, we do. So this is where I show how wonderful an artist I am. So if we just imagine a bog standard graph, right, in order to do a prediction, you'll see why I'm a psychologist and not an artist in a moment. Okay, what SPSS wants to happen is it wants to have all the kind of dependency scores, the most severe scores up here, and all the no concerns scores here. Go on, let's really push the boat out. So you can actually see that idea. Yeah, you get the idea. Okay, what it doesn't want to do is have all the scores mixed up. Similarly, if you find that you've got any categories which are not represented, so categories in the middle, it will also throw its toys out the pram and say, you want me to do this sort of ordinal regression, but you've clearly not got cases represented. So it's important that you A, have equal numbers in the cells, and B, have what's known as you meet the assumption of separation. Yeah? Okay, so that's the art class over. So it's warning us in this case you do not meet the assumption of separation. Now it may well be that you can bootstrap this, or you can say that because it's such a low sample size, this is what's causing you issues. Equally, you might find that you've got such a low sample size that you've not got a particularly good fit for covariance and coefficients. Right, so now if you look at model fit information, you'll see that you've got 0.00. Now this is excellent. Before we crack open the champagne, you might want to bear in mind that this is heavily affected by sample size. So actually you can see that you've got a relatively high chi-squared, but bear in mind that you will have a low sample size, so it could still indicate that you've got model fit issues. And equally, when you put that on its head, you get a chi-squared of 1, which would once again suggest that. Pseudo R squared, I would just ignore, it's fairly pointless. And then if you look down here, the first thing you want to do before you use any of the coefficients is you want to see if they're significant. Now, as a psychologist, you'll want to see if it's significant, as in if it's below 0.05. As you can see, that not a lot of them are. So what you would typically do is a power analysis to reveal what power you achieved, and then look at what power you then have to get in order to get a decent sample size. Equally, if you did have a significant result, then we could have a look at that. And as it's compared to various reference categories, you'll find that you've got lots of minus scores, which would normally be a good thing, but you can't take that because you've not got significance. And then you've got cell information, which is like a cross tab. Okay, then you've got tester power aligned. It's not showing anything there because you've not achieved significance in anything up in this table here. Well, I remember the last thing you'll want to do is just have a quick look at the graphs. So remember that I told you to save the predictive scores. So if you go and graphs chart builder, you want to put your predictive scores down here. You can put year down here, and you can put deliberate self-harm down here. Your predictive scores just tell people what categories they're likely to fall into. Yeah. And then if you click OK, then you can see that according to this, you've got lots of the potential of missing variables for hazardous and harmful, and you've got a very much dichotomy. So one thing you might want to consider doing then is recoding your variables into 1 and 2, and then just running a bog standard logistic regression, given your sample size. You can also do kind of line graphs as well if you want to see patterns. Like so, close. So if we've got predictive categories and deliberate self-harm, you can see that you've actually got quite a trend there. So you've got, obviously you've still got the problems with that, but you've clearly got the cause no concern being much higher for deliberate self-harm, which was your original hypothesis there. So this is something well worth investigating and well worth recoding your variables into a dichotomy. Okay, good luck.